What's up, the CodeBytes family? I am here with another interesting topic, and it is about C# interfaces through the eyes of senior developer. If you want to avoid basic explanation with poor examples, then this tutorial is absolutely for you. Cause if you are watching my channel, it means you are looking for a good quality content with professional examples. You want to level up your C# practical skills. We are not just going to talk about C# interfaces, but also later binding, reflection, professional object-oriented programming, and software design. I am so excited. Let's get started. Before diving into details, let's talk what we are going to develop at the end. Actually, we are going to develop ATM application. We'll have two applications, WinForm application and WPF application. They will share same code base using the library-based decomposition. They will have completely same UI, completely same functionality. The purpose here is to help you to understand how library-based decomposition helps us to share code base between different technologies. This is our WinForm application. Actually, from the first glance, it seems really easy, but when you dive into details, you understand that it requires a lot of effort to develop this application. This is our libs folder, and in the libs folder, we have different libraries. Actually, we have a library per provider. So we have Eden0 bank provider, private NM bank, private NM bank provider. If I exclude this library private NM from the libs folder and reload project, system will automatically check the libs folder, will grab the libraries, check the proper contracts, and will draw elements like providers in our case. Now we have only one Eden0 bank provider. When I click, it is possible for us in another window check balance and add to balance. So let me do the rollback operation here. I am moving the private NM bank to the same folder, and after refresh, you see that we have now two providers. Actually, we will talk about C# interfaces, later binding. We'll talk a lot of another interesting stuff like software design, proper object decomposition, and professional object-oriented programming principles to develop this application. Okay, it is time to dive into details. First things first, let's see what we have in our agenda. We'll talk about why interfaces. We'll talk about later binding, what, why, how. Oh, sounds really interesting. We have the ATM we are going to develop. We have technical specification about the ATM application. We have proper object decomposition like a senior. And at the end, we'll develop ATM application using object-oriented programming, interfaces, and dynamic binding. So why interfaces? Using interfaces, we are able to create loosely coupled applications. In our scenario, we have application and we have Eden0 bank provider. It is actually a class, the concrete class. And when our application directly uses Eden0 bank provider, it means we have tightly coupling between application and the class. But if we want to change this communication, we want to create loosely coupled mechanism between our application and our class, we are using interfaces or abstract classes. Even the direct class usage is also maybe a loosely coupling. Remember this, because the every class is already encapsulating some logic. If you don't need to abstract from the class implementation, then there is no need to use interfaces and abstract classes. But for now, we are using interfaces to isolate us from the concrete implementation of our bank provider. Now we are able to use Eden0 bank provider or private NM bank provider instead of this interface, because our application directly communicates with interface rather than their implementation. It is implementation. From the flexibility perspective, again, we have application, we have a bank provider, our application uses a bank provider, and now we are able to use any of this implementation in our application. So we have flexible behavior changing depending from our architecture. Our application is also maintainable when we use interfaces. What is maintainability in this case? We have application, we have a bank provider. A bank provider provides a strict contract. So our application uses this strict contracts. And it means we are not breaking this contract even we implement different versions of these interfaces. It means add-ins or bank provider, private and bank provider will provide a different functionality, but we are able to rely on our interface. So we are not going to break anything in our application. Polymorphism, wow, it is really interesting. So in our application, we have polymorphic behavior. Polymorphic behavior is when you have one contract, but this contract has multiple implementations, and depending from your requirements, you are able to change these implementations. Actually, this is a polymorphic behavior in our application. What else? We have more readable and understandable code. We are able to reduce complexity when we use interfaces. Interface helps us to create more testable code. And from the extensibility perspective, interfaces, I think, the number one tool to use. That's actually all about interfaces. Well, how about late binding? Late binding is actually dynamic binding. Late binding refers to the process of determining the actual method to be called at runtime rather than a compile time. It is really important. When you compile your application, you are getting a single artifact as your application. And using late binding, it is possible to extend your application without affecting your core code base. It is really important. We are using late binding in a lot of applications. For example, in Chrome, Firefox, in Visual Studio, they have a common behavior called extensions. So say you are working for Google Chrome, Google team, and you are developing Google Chrome. You release the Chrome, and it is possible to extend Chrome without affecting to its source code. So you have a single source code, but somehow it is possible to extend its functionality without opening a source code and adding even a new line to it. For example, in your Visual Studio, you have extensions menu, and using these extensions, you are able to add as many extensions as you want. Say in my Visual Studio, my Visual Studio consists from multiple functions, and Visual Studio provides some type of adapter. And using this adapter, other people, a third-party company or other guys, other developers are able to add functionalities to this Visual Studio, even knowing it is source code, it is implementation mechanism. So we are able to extend some application, even having it is source code. It is really important. It is the main purpose of dynamic binding. Several reasons why late binding, dynamic binding. Late binding provides polymorphism, flexibility, loosely coupling. Several ways to use it. We are able to have late binding functionality in our application using virtual methods, using interfaces, using reflection. We'll actually talk about the second thing here about interfaces. Late binding can have a negative impact on your performance, so it is not a good way to implement late binding for all your applications, but depending from your requirements, you are able to use late binding, dynamic binding in your application. Okay, now it is time to talk about the ATM we are going to develop. We are developing an ATM with the possibility to fill bank accounts. The third-party services, in our case, they are banks, and our developers using our contracts should be able to create bank APIs and provide them as a library for us. The important thing here is we should be able to add, remove application functionalities without modifying a line in our application. It is really important. We will develop two applications, Windows Forms and WPF application. They are actually going to be our real ATM replacers. Let's talk about the classical implementations that doesn't fit to our application. In a classical implementation, we have our application and we have our developers. And if we want to integrate some bank to our application as a provider, we should get some API from the bank side. You see, we have 3 APIs in our scenario. And we should develop some functionality based the API we get. So here, the client side, the banks are defining the rules. So per bank, we have different type of methods, different type of functionalities, different type of arguments. And we change the source code whenever we need to extend and change functionality. This is really important. The responsibility on our side. Bank should provide only API. Interacting with API, defining the flow is our responsibility in our case. But how about dynamic and late binding implementation? In this case, we have application, but in our application, we have some type of extension point. We have some type of adapter. We have, again, multiple banks. Even we have developers, a single developer. And these banks will provide a library for us. But they may have different libraries. For that reason, we have one single contract for all banks. So, for example, we have some type of interface with two functionalities. All these banks should implement this interface with two functionalities because we are defining the rules. No changes will be required in this case for our core application because our application interact with this contract, with this interface. So it doesn't matter the internal implementation for this contract. It is really important. So the dynamic late binding implementation fits in our case for our ATM implementation. This is our object decomposition for our ATM. So you see we have decode bytes, we have decode bytes WPF. This is our Windows Form application. This is our WPF application. And for Windows Form, for WPF, we have common contracts and implementations, and we will create a third mini application called decodebytes.common. So we have decodebytes.windowsform for Windows Forms, decodebytes.wpf for WPF application, decodebytes.common for Windows Form and WPF will share the same code base for two applications using a library called decodebytes.common. And this is our adapter, decodebytes.provider. So any bank is able to take this class library, extend iBank provider, and provide us this extendability as a library. And we have some folder in our application. We'll put this DLLs to this library, and our application automatically will scan, will grab the functionalities from this library and will draw a UI for us. This is how actually we are planning to develop our ATM application. I guess it is enough theory, and let's jump right into Visual Studio. Let's go to File, New Project, and let's select Blank Solution in this case because I am going to have multiple projects in one solution. My path is C Project Playground. You can select a location for your project, and let's have the Decode Byte Solution as our solution name. So the purpose here is to build the initial architecture for our application. In our application, we'll have this type of architecture. We'll have decodebytes Windows Form. It is actually our Windows Form application. The same is applicable for decodebytes WPF. It is our WPF application. We'll have decodebytes.common for the common functionalities to our applications for Windows Form and WPF. And the last thing is decodebytes.provider. It is really important. This will contain our contracts for our banks to be implemented. Okay, let's right click, add new project. I'm going to have first WPF application, and let's call it decodebytes.wpf. For now, I'm not going to dive into details of WPF. This is going to be a .NET 8. In my case, you can use any .NET version. Okay, let's right click, close all tabs. Let's go for another project here. It is going to be our Windows Forms application. Let's select from the platform Windows, and let's search for forms. Next, the code bytes dot WinForm. Let's hit next, .NET 8, and that's also okay. And then right click, add new project. The class library is going to be our decode bytes.common for Windows Form and WPF. Next, .NET 8, create. Cool. And let's, from the Windows Forms dependencies, right click, add project to common. And for the Windows Form WPF, let's do the same operation. Let's add the code bytes common for the dependencies. And the last one here from our side is going to be our class library called decode bytes. Decode bytes dot provider. Provider. Next, .NET 8. Cool. And actually, we will develop our providers. For that reason, I'm going to have a folder called providers. And this folder will actually contain all the providers we have in our application, like private NM bank, Eden Zero bank provider, and etc. Okay, let's add them also, add new project, our class library. They are going to be a DLL file, so we'll create a class library for them. Okay, decode bytes dot provider dot Eden Zero bank. I think that's all. Let's create. Let me just copy this name .NET 8, and same is applicable for another bank called private NM bank. Okay, private NM bank. And we will have dependencies from our provider, the code bytes provider. Same is applicable for Eden Zero also provider. Well, that's actually all about our application structure. Let's first start from our provider. So the code bytes.provider is going to be our main contract between us and our clients. In this case, our clients are going to be Eden Zero Bank, private NM Bank. So right click, add new item, iBank provider. This is our public contract, so it should be public. Why? Because I want to use it not just inside my library, but outside of my library. What type of functionalities do I want to have as a contract element between us and our contractors? So I want to have string provider name. It is going to be only get functionality, and void add to balance. And let's say we have string card number and decimal amount, and of course decimal check balance, and of course string card number. The problem here is every time I need to check my card number to be valid as a card number. So I don't want to have this type of validation everywhere in my application. I don't want to spread this functionality in my application. So what I'm going to do is actually creating a domain entity for it. Right click, add new class and card number. So for my card number, it is also going to be a public. So I am creating a constructor that will encapsulate string card number and will do all the proper operations related to card number. So card number, cool. It is going to be the public string number, just number is enough. Get, I guess a get private set is okay. So the number equal to card number, but before it I need to validate my card number. So what I'm going to use is regex dot is match Actually, we'll use a different type of pattern matching mechanism. But for now, let's use D4, 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 and D4 again. So for the card number, we should have 4 digits. Everywhere we should have 4 digits. I'm not checking if it is Visa or other card. So it is completely okay to have just card signature. So the first argument is going to be our card number, and if regular expression returns true, then set. But for the new version of .NET, we have generated regex attribute, so let's use it. It is going to be card number expression. So this will create a partial class in our case, and we'll have a proper regular expression template here. Okay, must contain, it is not important. So we have now, let's remove unused namespaces here, and for the card number, let's go for the card number class itself. Cool, now we have a contract for all our banks. Cool, let's go for Eden0 bank and implement it. I'm going to delete it. I'm always doing it. I'm not sure it is a good way of doing this. It is possible for you to rename, but anyway, let's create a class for it, Eden0 provider. Okay, provider. This is my Eden0 provider class, actually for Eden0 bank, and let's make it, of course, public, and let's implement our iBank provider. And let's implement it. It is going to be, the name for our bank is Eden0 bank. Okay, for the add to balance and check balance, we actually need to use REST communication between our application and bank. And of course, you are able to use a repository or service, etc., depending from your requirements. But actually, in my case, I'm not going to make our application complex in this case. So we'll use in-memory data structure to store all the information related to cards. So what I am going to do, I'm just going to create private, read-only, of course, and dictionary, string, decimal, cards, actually, cards. Okay, let's create our constructor. It is not going to be a new dictionary empty value, so I will do some loading operation. So let's create private dictionary string decimal load cards. Actually, as I said, it is not a good way of implementing it, because you should use your service layer. You should communicate with your, let's say, database directly. But in my case, we are using in-memory structure for it. Cool. Load cards. Let's just write load cards here and return new dictionary string, and let's have our card number 111 222 333 and 444 with decimal amount 400. Cool. And for the another key, we are using 111 333 444 and 555, and let's set as a default value for this amount. We have, for this card number, we have 900, and for the first one we have 500. Cool. 2 cards are actually enough for us, and let's do add balance operation. For the add balance, check if is card exist, and let's check the card number. If the provided card exists, we are going to cards, card number, and let's add amount directly. Otherwise, let's just, it is better just throw exception, throw new exception. Let's say card number is not valid. Truth be told, I don't like to throw exceptions everywhere. It is better to use result pattern. It makes your code more clear, more understandable, more maintainable. But for now, just throwing exception is enough. We'll have a separate topic related to the result pattern. But for now, let's throw some exception here and let's go to implement our functionality. Okay, and let's check. Let's do in this way. We have cards dot. We have multiple ways of checking our dictionary actually. I'm just using key equal to number any. For me, it is completely okay to have such type of implementation in my application. And for the check balance, we are going to use a same functionality here. Let's just copy this template, paste it here, and if it exists, return cards, card number, otherwise card number is not valid. So this is going to be our implementation for Eden Zero Bank. Cool, now it is time to switch to a private NM bank, and let's do the same operation for it. We'll have a little bit different implementation for that. So private NM provider. Okay, and let's implement iBank provider. Let's make it public and let's implement it for provider name. We are going to have private name bank. We'll use reflection to get all this information, like calling add balance, check balance, and we'll get this information from our Windows form and WPF application. Actually, for the add balance, I'm going to use approximately the same functionality. Let me just copy all of them from here. Actually, let's just make them more understandable to copy. Okay, let's paste it here. And it is our private NM. The only thing I am going to change here is actually, let's first change the card numbers and the implementation related to add balance. We have some fees when you add some amount to your balance. Unfortunately, this is possible for some banks. So let's do it. Private decimal, it is going to be private const decimal fee equal to 1.2 decimal value. Okay, and before adding to balance, we should calculate fee. So how we are calculating it? Actually, we need to take this amount and divide to fee, and from this value let's subtract our amount, and it is going to be decimal original amount for us. And for this one, I'm going to create a separate functionality, private decimal calculate fee decimal amount. Okay, and let's return the calculated value here. Now we have calculate fee. Okay, and let's use it. Calculate fee amount, and let's add the original amount rather than the amount. So let's say it is going to be static. You can use inline function or etc. type of syntaxes, but for now it is completely okay for us to have this type of syntaxes. Cool. Now we have implemented our provider layer, our private enum bank, and Eden 0 bank. Let's check what we have so far. We implemented a bank provider with two methods, add to balance and check balance, and also we have one property called provider name. We have Eden 0 provider and private enum provider that implements this interface as a separate class library. It is possible for you to extend and add additional libraries, but for now, only 2 implementations are enough for us. And what we are planning to have in general. I created a diagram for you. This is our diagram. We implemented this part here. And the missing parts are actually our decode bytes common with WPF and Windows Forms UI implementation. In decode bytes common, we are planning to have 2 interfaces. First interface is going to be a provider service. Why? Because the purpose of this interface actually to grab bank provider implementations from different sources. I mean, from different type of implementations. For now, we are going to use late binding implementation. We'll have libs folder in our Windows Form and WPF application, and default provider service is going to scan libs folder and grab all the required classes based on a bank provider interface. The other interface is going to be a provider visualizer. Actually, this interface is for UI elements. So we have WPF and Windows Forms. As you can see, it is implementations live in Windows Forms and WPF. Per technology, we have different type implementation. I provider service we have, it has only render providers functionality, and WPF implements it using WPF-based mechanisms, and Windows Form will implement it using Windows Forms-oriented mechanism. Okay, we have iProvider service. Its implementation lives in default provider service, but iProvider visualizers implementation will live in our different technologies like WPF and Windows Forms. So let's start with decode bytes common. Let's go for decode bytes common. I am going to create 2 folders here. Add folder contracts and right click, add folder implementations. Actually, contracts is going to be our interfaces. In this case, implementations. Cool. We will put all the interfaces to contracts folder, right click, add new item, iProvider service. Let's first start from my provider service and its implementation. For iProvider service, let's check what we have in our diagram. In our diagram, we have get providers as a single method, and it should return iBank provider collection. Okay, so enumerable iBank provider and get providers. And also let's right click, add project reference. We don't have reference to iBank provider class library, so let's add it. And let's add using here. The purpose here, again, I want you to understand the main purpose here. We have different type of library grabbing. For now, we will have libs folder and we'll take all the libraries from libs folder. We'll put our providers to our Windows Form and WPF's libs folder, and this interface's default implementation will check libs folder and will get all the required operations related to this folder actually. Let's remove this. Okay, and for the implementation, right click, add class, and it is going to be default provider service. Okay, It is also going to be public. Why? Because we are going to use this implementation from our Windows Forms and WPF. Provider service. Let's implement it. Cool. Okay. Now let's try to implement our functionality. What I am going to have, I am going to private string private. Let's have it as a constant string, and for the folder name, I am going to put libs folder. This is going to be our constant here. Okay, we have multiple constants in our case, so string extension. What we are going to scan, we are going to scan for DLLs actually. And private read-only string, the original libs path. This is our constant libs folder. Our DLLs we are going to check as an extension, and from the constructor, let's define our libs. Let's set underscore, and libs will take from application path dot path to, of course, folder name. We don't have application path to functionality. I am going to isolate path scanning mechanism from provider service, because provider service is actually responsible for getting providers rather than defining complex paths and adding functionality related to these paths. So I will have specific class here. It is going to have a static class. Okay, application path. And for the application path, it is going to be public static. If you actually want to have different type of behavior for your path combinations, you should definitely use interfaces for this implementation also. But for now, it is enough for me to have just simple path getting mechanism. So I'm just going to have public static string path to and string folder. We will define our folder name, and system will automatically get a path for this folder. For example, in our Windows Forms, we will have right click add libs folder. That's all. And we will provide libs folder name to this path to method, and system will automatically detect that the full path of this libs folder. So let's right click, open File Explorer. So we have libs here. So you see this is my full path. So system somehow should get this path for my application. Okay, cool. What I'm going to do here, I will use path. It should be get full path. Yes. Path dot combine environment current directory, and let's add like this, and of course the original folder. It should be folder name rather than folder. Okay, cool. Now it should work. We'll check it. But for now, let's see. Okay, everything is working. Now I want to implement get providers. So what I have here, I'm going to have string folders, and I will use directory, not get directories, but get actually files. So get files, and let's go for the extension. It actually not extension but search pattern. You can rename it search pattern. For the extension it doesn't matter. Actually it is better to rename search to search pattern. Cool. Now we have all the files from this directory. Okay, so let's have for each files file. Okay, our files are in a string type. Cool. What I am going to do, I am going to get all these files, I mean all these DLL files from libs folder, scan their context, get their types, and check if we have proper type that match iBank provider. In general, if we have some type of classes inside these libraries that implement iBank provider, if yes, then using activator create instance, I will in runtime create their instances and return them as a bank provider. Okay, so now we have all the files. Now I have a single file here. What I'm going to do, I'm going to assembly dot load file, actually. Okay, let's have it as an assembly instance, assembly. Okay, now we have assembly. What should we do? We should get all the types from this assembly. So let's go for it, assembly dot get types. Type array assembly types. Cool, I have all the assembly types. What I am going to do here is for the assembly types, I am going to check using LinkQ if we have the proper interface implementation here, name of iBank provider. Okay, ignore case. Yep, ignore case. Cool. And we have, let's do a little bit formatting here. What we are getting are enumerable types. Enumerable type, original types. Let's just call it like original types. The original types we are looking for. Or you can use iBank provider types. Bank provider types. Cool. Now we have bank provider types. And what should I do? I need to do again for each bank provider types. Oops. Let's just copy, paste it here, and bank provider type. Let's do formatting, and I need to create instance for that. Let's using yield return the activated instances. I want to have this instances as a iBank provider. So activator dot create instance from bank provider type. That's actually all about the implementation for default provider service. The purpose here, using reflection, check predefined folder and get iBank provider instances. That's actually all about the responsibility for default provider service. Okay, cool. We have implemented iProvider service with default provider service. Okay, let's implement iProvider visualizer. Right click, new item, iProvider visualizer. The responsibility of provider visualizer is actually to making our Windows Form and WPF application classes clean. The purpose here is not to directly code all the visualization functionalities to your Windows form, to your WPF. Instead, isolate it to iProvider service and make it really understandable and to create a better application. So let me make it public. So what I'm going to do, I'm going to have void render visualizer. Of course, it is not a complete better implementation. Depending from your technology, you may change this signature, but for now, for me, the Windows Form and WPF, this type of signature should be enough. Let's call it render providers. Let's see what render providers. Cool. Let's remove unnecessary namespaces. Cool. And for the implementation, let's start from Windows Forms. Okay, I'm going to my Windows Forms, Form 1. What I really want to do here is let's go for properties. It takes some time for Visual Studio to somehow load the designer. Let's wait for it. Okay, let's right click properties. I really like in my UI applications to have proper name and text. So it is going to be decode bytes dot, let's say decode bytes UI. Okay, the text is decode bytes UI. And for the name, let's find the name here. Okay, okay, and let's call it main forum. Cool. And also to do some UI stuff like change forum border style to fix a tool window. Let's add also group box here. Group box. Cool. We will add all the providers inside our group box. Let's call it providers. And let's rename it group box providers. Okay, cool. And also from here, I guess that should be enough. Let's have implementation for provider visualizer. And it is going to be just right click, add new class. Provider, let's call it like, let's see now, form. We have forum provider visualizer. Forum provider visualizer. Let's make it. Let's see, it should be internal in our case. Right click, add project reference. We have reference to the code bytes common. It should be enough. And let's inherit from iProvider visualizer. And let's implement it. Cool. What I am going to implement here, actually, I will provide my group box to my provider visualizer. And this provider visualizer will actually fill this group box with the required iBank provider implementations. So actually what I'm going to do, I will have a constructor, the private read-only. It's going to be my control, and from the constructor, let's have our control here, and let's store this control. Okay. For the render functionality, I will also have private read-only provider service. provider service. Cool. Now we have loosely coupled dependency from iProvider service, because I'm not going directly to use default provider service. Instead, I'm using iProvider service. What is the best option for you? The best option is here to provide our provider service from the constructor. But for now, you can use actually dependency injection or directly provide iProvider service implementation when you call form provider visualizer. But for now, to make things a little bit simple, I will provide the direct implementation from the constructor. So provider service, new default provider service. Cool. Now I have provider service. Maybe it requires default constructor, I guess. Yes. Okay. And let's go for render. Provider service, get providers. That's actually all. Now it is possible for us to get all providers. Now we have the providers with activated form. What I am going to do, I am going to have special mechanism to render my elements. How it is possible for you to do it? So you can just simply put some button to check its size. For example, you want this type of button to have it as a provider button in your application. So let's check its properties. So we have this type of size, width, and height, and let's use it. So for the provider, I am going to have button. Okay, for the button, let's use size, new size. Okay, let's check it again. We have 134, okay, and 97. Cool. And for the text, let's go for provider dot provider name. Cool. We'll use provider name as our text in our button. So we also need to have some type of default location. Private, let's have it const. For the location, let's check the location first. So I have location 34, 38. Okay. Location X. .34 private, private const integer location y4 it is 38. Cool. And let's have it as a location equal to new point, and let's provide I guess it should be X and Y. And after having this button every time, we need to do some additional changes. Like for example, for the next button, let's copy and paste it again and create some type of alignment here. For the next button, I want to be rendered like this. So let's check my location. So you see the X will be changed, but Y will stay same. So for the location X, every time, let's increase it for 160. Okay. And of course, it is const, but let's remove this const. For now, you can use it as a const and create another variable to make location X to be reusable. In this case, that should be enough for us. And let's add to control. Every time we need to add this button to our control. Controls dot add our button. Let's remove this one. Let's remove all these buttons. Now in our Windows form, we don't have any buttons. I want to set it as a default project. Okay. What I am going to do, I am going to call my form visualizer when our form loads, okay? And I will call render providers. This will go to our get providers, we'll get all the providers, and we'll create button per provider and add it to our control actually. Okay, let's go to our form load. In our main form load, I'm going to call our provider visualizer. Okay, form provider visualizer, new form provider visualizer. Let's provide our group box providers and form provider visualizer dot render providers. Let's run our application. We don't have any library yet in our libs folder, so it will check there is no library, so nothing will be shown in our application. Let's just right-click, build, for example, Eden0 bank. Let me right-click, open File Explorer, go to bin, debug, .NET 8, take decode bytes, Eden0 bank implementation, copy this, and let's paste it to libs folder. And let's run our Windows Form application again. And voila, we have Eden0 bank. Let's continue with our Windows Form implementation, where I want to change the private NM bank provider name. Let's private NM bank, and right-click, build it, and right-click, open it in File Explorer, bin, debug, .NET 8. Let's take private NM bank library and let's paste it to our libs in Windows Form and check if everything is properly working or not. Cool. Now we have properly working the providers. What we are going to do actually is to do some additional changes in our UI to support reload providers functionality. Okay. Let's add our button like this. Reload providers, and of course you need to change name. I always call them button reload like this. Let's double click. The purpose here is to reload the providers when we directly manipulate to libs folder after application running. Before calling the new form visualizer dot render providers, we need to clear our group box because we already have some type of components in our application like providers. Okay, now everything is working. To check if things are okay, I'm just going to open the libs folder here. Libs. Okay. Run our application. Let's check. Let's take private NM bank. Paste it here. Reload. Cool. Let's do roll back. Reload. Cool. Everything is working. Now it is time to implement internal functionality, like, for example, when you click to the provider button, it should open a new window with proper components. For that reason, I am going to add new form called balance operation form. We'll do two operations, check balance and add to balance. Let's close it. And for it, let's go to our provider visualizer. In our provider visualizer, we need to add some type of event to our button. It should be, let's do it this way, button click. Okay. And let's generate some functionality here. And what we are going to do, we are actually, you can't really use even lambda expression rather than functionality like this. So we have sender, orgs, and let's have our provider. I just want to instantiate new balance operation and provide my provider from the constructor to not to every time get this from the interface we have. And let's call it as using show dialog. Cool, I don't have this constructor. Let me add it. Let's go to definition. Now we have iBank provider interface dependency. Private iBank provider, bank provider, bank provider. Let's also rename it as a bank provider. Cool. Now we have bank provider. And let's go to our balance operation. What I'm going to do, I want to design some UI here. Truth be told, I hate designing, but anyway, nothing to do. Let's do some design. Text box, add our text box here. Okay, right click, properties. Let's make it, of course, fixed tool window. And what we are missing, our two buttons here. One for check balance, the other one add to balance. Add to balance. And let's copy this, paste it. Okay, let's wait. Cool. Right click. Check balance, and let's rename it button check balance. And of course, button add to balance. And for the label, let's rename it to card number. Let's copy these two elements and let's rename it to our amount. And of course, rename it to text box amount with text box card number. Cool. That should be enough for our UI. And let's go for check balance. The functionality check balance should check our balance. So I already have bank provider, check balance. I need to provide some card number. And of course, I will provide it using text box card number dot text. What you should do before it, of course, if string is null or empty, text box text. You may use any type of validation library, but for now, this type of validation should be enough. Else message box dot show provide a valid card number. Or you can just call it from the check balance and catch exception and show the message. Again, throwing exception is not a good way. You should use another patterns. for proper implementation of exception handling like result pattern, but for now, that should be enough for us. Okay, and check balance returns some decimal value, decimal balance, and let's just show the result. Message box that show balance to string. Let's run it. Cool. Let's go to Eden Zero Bank. Okay, we have 111, 222, 333, and 444. Let's check the balance. Provide a valid card number. Cool. The problem here is I forgot to add reverse operation for it. Okay. Come on. Let's run it again. And Eden Zero Bank, paste our card, and voila, we have the balance. Cool, everything is working. I want to check it for the private NM bank. Let's paste it, check balance. It should throw exception because we don't have this card number in our private NM bank. So just catching exception and showing the message will be enough for you. Okay, and let's go for add to balance. For the add to balance, we have again bank provider, come on, bank provider, add to balance. So we need some type of card number, our text box card number text, and the decimal amount, text box amount dot text, of course, with convert to decimal. I'm not checking if user provided some type of valid value or not because it is out of scope of our implementations. Just for now, the checking that add to balance is working should be enough for us. Okay, let's go for Eden Zero Bank. Let's paste 111, 222, 333, and 444. And let's first check our balance. We have 500. I'm adding 400. Let's again check. Now we have 900. Cool, everything is working. So let's go for private NM bank. 222, 333, 444. Let's first check our balance. 500. Let's add 400. If you remember, we have some type of fee. So it should calculate fee, then add amount. Let's check. Yes, we have some type of issue here. Let's go for it and fix it. We only need to change the calculation process here. It should be amount multiple to fee divide to 100. And let's right click, rebuild, right click, go to the file explorer. Let's take the library again, compile the library. Okay, let's go for libs folder. Let's remove the private NM bank from the libs and let's paste it. Let's run again and see if everything is working. Private NM 222, 333, 444, and let's add 400. First, let's check balance. Let's add, let's check. Now everything is working properly. Cool. We have fully functional UI with cool designed architecture. And now it is time to implement our WPF. The important thing here is, as you realized, our application will have balance operation, but this balance operation actually doesn't know which type of implementation we are planning to provide. When we click Eden Zero, we are providing Eden Zero instance. When we click to private NM, we are providing private NM instance. So this is how we are using interfaces. This is how we are using polymorphic behavior in our application. Just remember that. The last section in our practical example is going to be our WPF application development. We already developed Windows Form UI with the functionalities, and now it is time to have WPF application. Our WPF interface and functionality should be same as our Windows Form, but the only differences we should have is going to be our different behaviors from the UI perspective, because in WPF we have different type of components, and these components have different type of functionalities. For that reason, we created iProvider visualizer, and for Windows Forms, we have Form Window Visualizer, and for the WPF, it is going to be Window Provider Visualizer, okay? And also, for not to spending much time on our UI, I created some UI for us. For the main window, we have really simple UI. We have only grid with wrap panel, and from the balance operation window perspective, we have grid with multiple stack panels. So it is possible for us to have card number, amount, and also text boxes in our UI. Cool. And you can find the source code below in the comment section to the video. Okay, let's start our development. I'm going to right click at class. What I want to implement actually is going to be our window WPF oriented UI rendering process. So let's call it Window Provider Visualizer. Okay, we should implement iProvider Visualizer. Cool. We are going approximately to have the same functionality as our Windows Forms, but with few differences. For that reason, I'm just going to Form Visualizer and copy the functionality we already developed. Let me just paste and do the proper changes. Now we don't have control, we have panel. It is also okay to have control, but I'm going to change it to panel. Let's rename it panel. And for the panel, let's copy, paste, and make it panel. We have iProvider service with default provider service implementation. We have location X and Y. It is completely okay. But for the button, we have different type of properties. For the button, we have width equal to 134, and height, it is going to be 97. It is better to move these magic values to the configuration and read it from the configuration. But for now, to make the things really simple, I'm just using the direct coding process. Let's remove it, and let's change it also to content. In WPF for the button, we have content. And for the margining, we have, let's say, new. It is going to be, let's add our location X, location Y, and 0, 0. For the button click, we are going to have balance operation window. The balance operation window with show dialog. Cool. We don't have constructor, and also for the panel, we have panel.children.add. Okay, let's for the balance operation window add our constructor. Let's go for it. Let's say generate constructor, a bank provider. Okay, cool. Now we have constructor for it. Let's go and store our bank provider. Private, a bank provider. Let's take it from the constructor. Okay, bank provider. And by the way, I don't want to have default constructor. For that reason, I'm removing default constructor here. Cool, I have bank provider, and what I am going to do actually is approximately same as our window. So for the balance, let's go for it and let's see what we have. For the balance, we have few operations here. So you see we have the same implementation for the balance, and we have some functions for the button click. But before diving into the details of button click operation, let me implement the main window first. So for the main window, I have some main panel in my application. What I am going to do, I'm not going to use MVVM type of implementation. It is just really easy for us. Let's use the loaded event and let's view code. for the loaded, we should get all the information from our provider and load them. Okay, cool. And let's use the same implementation as in our Windows form. Okay, let's go for it. Let's just copy and go our main window and paste it here. Now we have window provider visualizer. Okay, window provider visualizer. Why I don't see it? Let me just copy. Okay, and go to window provider visualizer. Okay, window provider visualizer. Now I have initialized component. All the components have already been initialized. What I want to add the panel, our panel here. Okay, I think the panel name is main panel. Okay, and render providers. That's all from the panels perspective. And what else we need to have? Actually, we need to have the reload providers. It is also really easy for the reload. We'll use the same functionality. I'm just bypassing it. Let me just check the WPF if it is working or not. For now, we don't have libs folder. I will just create the libs folder right now. Let me just stop the application, right click, add folder, libs, and let's move some implementations to our libs folder. Let's run our WPF application and see if everything is properly rendered or not. Let's run. Okay, we have two buttons. So from the margins perspective, it is completely okay. You can do any type of margining and alignment for your buttons. It is completely okay. For the click, you see we have this type of window. And now we need to add these two button functionalities to our UI. Okay, let's go for the balance operation window. I'm going to find the buttons we have for the balance check. Let's add click event. And for the same behavior, let's add for the another button. Okay, cool. Now we have, unfortunately, I don't have the proper naming, so no worries. It is okay. So what I'm going to do, I'm going to actually copy the functionality from the forum. In our forum, we have check balance. Let me just copy. Check balance. Let's go our balance window and let's open our XAML file, paste it. So we don't have text box card number. Let's change it. So let's see the names of our elements in UI. Okay, for the balance, I have text box card number. Go to our balance window, text box card number, and we have texts here. Cool. And let's see if everything is working or not. For the provider NM, I have this type of card number 10022222333 and 4444. Let's check balance and see card number is not valid. Oh, okay. Let's check for the card number. Let's see, we have 1000. Okay, let's run it again. Let's go private NM bank. Let's paste it, check balance, everything is working. Okay, and now it is time to implement add balance functionality. For the add balance, we have button click. Let's copy the same functionality from our forum, actually. Okay, let's copy. And let's go for it. Let's paste. We have text box card number and Cool. Now we have approximately same functionality. As you can see, we implemented only a few code lines per technology, per Windows Form and WPF. We have mostly shared the functionality between our technologies using bank provider and the common library. Let's run it and check it again. I'm going to select add-in 0, 1, 1, 1, 1. 3, 3, 3, and 4, 4, 4. Check balance. It is working. Let's add 250 and the balance. Check balance. Cool. Now everything is working as we expected. So we have implemented the full flow of our application. Is that actually all? Well, from my side, yes, but I have a homework for you. You need to do some refactoring. What type of refactoring we are talking about? First things first, we are throwing exceptions. It is not a good choice to throw exceptions for expected cases. If you have unexpected cases, throwing exceptions is completely okay, but when you have expected cases, use result pattern instead. At proper validation, as you might expect it, we have some type of validation issues. We have the validations related to the text boxes, and also when our libs folder is empty, it throws some type of exceptions. So you need to handle them. You need to validate if everything is okay or not. And use proper service repo implementation behind the provider implementations. We have in-memory implementation for our card system for the providers. Use service or direct repository access to your providers. As Nanamin said, "Ato autonomimas." You take it from here. So that's actually all from my side. If you like my videos, please don't forget to subscribe, to hit like button, and if possible, please share this video. So see you in the next tutorials.